Good morning, student. Today we are taking the new unit, that is the Introduction to Trigonometry. Introduction to Trigonometry. So first of all, we see why we need to read or study about the trigonometry or what applications are there for the trigonometry. So in daily life, we see so many problems where we can use the trigonometry, or with the help of the trigonometry we can solve different type of situation. Suppose we can take some example from daily life. As you know that a student of a school visiting Qutub Minar, suppose this is the Qutub Minar, and student is standing at this point. Clear? And with the height of the student, and there is a distance between the Qutub Minar. Now suppose this student see at the top of the Qutub Minar, and if he or she wishes to find the height of this tower of Qutub Minar, so how he or she can find this height without approaching or traveling to the point A? So we need something extra. With the help of that we can find the height of the Qutub Minar. Similarly, we take the second example. Suppose a girl is sitting on the balcony of a house. Suppose this is the balcony of a house, and she is sitting in this balcony, and she observe a point on the road or any vehicle here, and she want to see this. Then how, without measuring this, how we can find the distance between the building and this object? Clear? These are the situations where we have to find the distance between the object and the building. Clear? And you may take more example, like suppose there is a river. Suppose this is a river, or width of the river is given, and on the bank of the river there are three, we can say A and B. So a person from this point C, a person at the point C observe the top of both the tree, right? Then again, with the help of this topic, so in all these situations we have discussed, we need the common thing. Either we have to find the height or distance. So the height or distance we can find under a branch of the mathematics that is known as trigonometry. Clear? Now we see that with this data, trigonometry comes from the Greek data, that is tri means three. Gon means sides, and metron means measure. So this Greek word meaning is trigonometry. This tri means three, gon sides, and metron means measure. It means we can say that trigonometry is the branch of the mathematics which deal with the study of a figure with the three sides, or measurement of a geometrical figure with the three sides. Clear? So especially we can see that trigonometry is the branch of the mathematics which deal the study of a triangle, means triangles, angle and side. Or we can say how to find angle, or what is the relationship between the angles and sides of a triangle. That is known as trigonometry. So this is very important branch of the mathematics we can see. Clear? So now you can see, first of all in this chapter we have different topics. In that we have trigonometric ratios of the angles. First we have trigonometric ratio, right? Trigonometric ratios of the angles. So what we mean by the trigonometric ratios? Trigonometric ratios of the angles. So when we consider a right triangle, here always we get a right triangle ABC and right angle at B. Yeah. So we consider any one acute angle, or we take any one acute angle either A or C. So that angle, with respect to that angle, what the ratio of the sides is there? What is the ratio of the side in accordance with the angle A? That is known as trigonometric ratio. Means we can say it is the ratio of the side of a triangle with respect to the considering angle. Clear? So generally you can take here angle as an acute, but when you go for higher study, this acute angle may be different type, or you can say it may be obtuse or more than 90-degree angle also. So that ratio we can generalize it for the higher studies. So here we can say if we are considering angle A, generally we can write either angle CAB, or in short form we write angle E. Clear? Now we can say name of the side. So one name for this side BC, which is just opposite to the angle A. Why we take angle A? Because we are considering the angle A. So this is known as opposite side. Opposite side. Clear? And we know that the side opposite to the right angle is hypotenuse. Side opposite to the right triangle is also known as hypotenuse. And now this side which is adjacent to angle A or considering angle A, that is known as adjacent side. Clear? This side is known as adjacent side. Clear? So we give the three names. Now according to this we have to find the ratio of the side of a triangle. Clear? So see how we can find the ratio, or we give a particular name of the particular ratio. Clear? Like say if we are taking this opposite side upon hypotenuse, if we are considering the side opposite to angle A, side opposite to angle A upon hypotenuse. Yeah, this is the ratio of the side opposite to the angle A to hypotenuse, that we can say give a special name. Now we are given, whenever you find the ratio of this side to this, that we have already fixed, and we give this name as a sine of angle A. This is known as sine of angle A. SINE, sine of angle A. This we can read it sine of angle A, or in short form, abbreviation form, we can also write SIN, sine A. So this ratio particular give a new name, that is sine A. So always whenever you are finding sine A, that means side opposite to angle A upon hypotenuse, and this side is BC upon AB. This is known as BC upon AC. Right? This is BC upon AC. So one may also call, when you see in a triangle or in a right triangle, we have perpendicular at base. So the side which contain 90-degree angle and considering angle, that is known as always base. This is also called as a base, or you can say adjacent side. And this is known as perpendicular. Perpendicular. So one may also write this is perpendicular upon base, P upon B. In short, we call P, that is perpendicular upon base. Perpendicular upon hypotenuse. AC is considering as a hypotenuse and AB is the base. That's why we write this P upon N. So this ratio. Now second, if you are taking adjacent side by hypotenuse. This is different type of a ratio, or its value will be different. So this ratio is given name as cosine. Cosine of angle A. We are writing here cosine of angle A, or in short form you can say cos A. So what is the cos A? It is the ratio of the adjacent side to the hypotenuse. Now adjacent side generally we are called in short form B. So this is known as base upon hypotenuse. In short, B upon N. Base upon hypotenuse. So that always called as a short form cos A. So these all are the Greek letters we are getting. In ancient time we are using. Clear? Now third C, we take the ratio of the opposite side or side opposite to angle A, or in short we write opposite side to angle A upon adjacent side. Adjacent side. So this is known as tangent. We have new name, that is tangent of angle A. Tangent of angle A. Is it clear? So you can write this is tan A. In short or abbreviation form, we have to write tan A. So what is the tan A? Tan A is always the ratio of the side opposite to angle A by adjacent side. Now in other form, this is known as perpendicular upon B. So there are three main ratios we call sin A, cos A and tan A. Clear? Now if you take the reverse of all these three, means converse tan, hypotenuse upon side opposite to angle A, hypotenuse upon adjacent side, or adjacent side upon opposite side to angle A. So we get three more ratios. See, if you take first, we take this hypotenuse upon side opposite to angle A. So now this is known as cosine. This give name as a cosine. Hypotenuse upon side opposite to angle A known as a cosecant of angle A. In short, if you write cosec A, in short we can write, so hypotenuse upon side opposite to angle A, that is called as cosecant of angle A, or in short form we can write cosec A. Clear? That is cosec A. So hypotenuse upon side opposite to A. So hypotenuse upon side opposite to angle A, that is the perpendicular. Similarly, we have secant A. Secant of A, that is in form sec A, which is hypotenuse upon adjacent side. So that is H upon B. So these are just reciprocal of these two. Now third, reciprocal of tan, that is cotangent. Cotangent of angle A. In short form we can write cot A. So that is the reciprocal of this. So we can write adjacent side upon opposite side. Opposite side to angle A. So that is B upon P. So you can say there are total 6 trigonometric ratios. We have 6 trigonometric ratios which establish the relationship between the sides of a triangle and angle. Clear? So that is very important. In short form now we write what we see here: sine A is perpendicular upon hypotenuse. Then we have cos A base upon hypotenuse, and then we have tan A is perpendicular upon base. Now reciprocal of these, reciprocal of sine, that is cosec A, reciprocal of cos, that is sec A, reciprocal of tan, that is cot A. So cosec A will be H upon P, sec A reciprocal of cos, so H upon P, tan A B upon P. So we have these 6 trigonometric ratios. On these 6 trigonometric ratio, whole trigonometry will stand. Or you can say this is the basic thing for the trigonometry. So these 6 are very important, you have to remember. Clear? So you can easily remember all these lines we are checking here: P, B, P, and H, B. These 3 are there. Then other we can see easily. So in short form, this is the sine, this is cos, and this is tan. Clear? So you may remember by Pandit Badri Prasad here are both. So what we can say: P upon S sine, B upon S cos A, P upon B, that is tan. So Pandit Badri Prasad are both. So you can easily learn the sine, cos, and tan. Then their reciprocal, here you can take S upon P, that is cosec, S upon B, that is sec, and B upon P, that is cot. So these 6 trigonometric ratios are the ratio of the side of the triangle with respect to the considering angle. This acute angle. This is clear? Now we can see, you have to remember always this formula. Now the sine A, cos A or tan A, that means if you are using, then we are very careful. Here sine A, if you are writing, it is not that it is multiple of sine and 2A. That is wrong. Here sine A means separately sine have no meaning. If there is no A or angle, then it has no meaning. Or it is not multiple of sine and A. It is what? This is the operator. Sine of it. It is given there. Sine A is the operator. What is the value of sine A? That is the ratio of the perpendicular to hypotenuse. Similarly, if you talk about the cos A, again this is operator. The meaning of cos A is it is the ratio of base upon hypotenuse. Clear? And similarly, other trigonometric ratio, they have no separate meaning. Cos and A, these have no meaning. So always you write with the sine A or sine B or sine C or whatever angle may be there. This angle may be different. Now here you see we are talking about that cosec A is reciprocal of sine A. So what we can write? Cosec A is equal to 1 by sine A. Or if you cross multiply, then cosec A into sine A is equal to 1. This is very important identity or rule or formula. Cosec A into sine A, that is always equal to 1. Similarly, sec A. Sec A is the reciprocal of cos. Means sec E is equal to 1 upon cos A. So what we get? Sec A into cos A equal to 1. So this is the second. Similarly, cot A is the reciprocal of tan A. Cross multiply. So we get cot A into tan A equal to 1. So these are the three identities. Means one can be replaced by these values, either cosec A into sine A or sec A into cos A or cot A into tan A. These values. Now one very important result. Suppose if you are dividing sine A by cos A from the figure. If you are taking sine A, so sine A is the ratio of perpendicular upon hypotenuse and cos A divide base upon hypotenuse. So H cancel, so we get P by B, that is perpendicular upon base, and perpendicular upon base is tan A. So what we get? This is also very important formula, that is sine A upon cos A always equal to tan A. Means tan A can be written in terms of sine and cos. We can write tan in terms of sine and cos. Similarly, reciprocal of tan is cot. So one may be write cos A upon sine A is equal to cot A. So these are important results you may write. Clear? So with the help of these trigonometric ratio, we can solve different type of a problem. Now very important thing we can discuss here. If we are increasing the side like a different triangle, angle remains same, then this ratio is a constant, because as this the length is increasing, corresponding hypotenuse is also increasing. So whatever triangle may be, if theta or angle A is same, then the value of the trigonometric ratio is also same. Means if we are taking for this triangle, small triangle sine A, or for this triangle sine A, or for this triangle sine, all have equal value. So values of the trigonometric ratio does not depend on this sides. If angle is equal, if angle is changing, then the value is also changing. Clear? Now we see very important result, that how to find the side of a triangle. So we take one example. So see, this figure you have to remember, or how can you learn these ratios that we have seen. Now see example what says, given tan A equal to, we are given tan of A, or you can short name as tan A equal to 4 by 3, and say find the other trigonometric ratio. Find the other trigonometric ratio. Means we are given one trigonometric ratio tan A, and we know that there are total 6 trigonometric ratios. So with the help of one trigonometric ratio, how we find the other trigonometric ratio, that we have to see. Clear? So we know that tan A is the ratio of which side? Suppose this is our triangle, this is angle A, this is B 90 degree, C. So this is perpendicular. If you are considering A, then this is base and this is hypotenuse. And we know in solution you write tan A or tan equal to perpendicular upon base. So perpendicular upon base. Perpendicular means BC or base means AB. Now this is given what? 4 by 3. We are given the ratio of the side perpendicular to the base. That is, if perpendicular is 4 unit, then base will be 3 unit. Therefore, we take, this is the only ratio is given, not exact value. It is not given that this is 4 unit. It is ratio. Right? Means if this is 4 centimeter, this is, if it is 12, that is 9. You are multiplying with the same factor. So you can write therefore if BC equal to 4K, because it is ratio, as in earlier class you also see, where we are separate the ratio, we take a variable x or y. Here we are taking K. You can take any. Then AB equal to 3K. If BC equal to 4K, then AB equal to 3K. This is. So now using Pythagoras theorem, we can find third side, because two sides of triangle are given. So we know by Pythagoras theorem what? AC square is equal to AB square plus BC. Hypotenuse square equal to perpendicular square plus base square. So we have to what? Find hypotenuse, because perpendicular and base both are given. So put the values 3K plus 4K. That square 3K, that is 9K square, 4K square, that is 6K. So we get 25K. This is the value of AC square. So tan square root on both sides. 25 square is 5, K square and square we cancel. Right? AC square equal to 25. Square root to this side, then we get square root. So square root of 25, 5, square root of K square. Right. So what we get? We get this also as a 5K. This is 4K. So we get all the three sides of the triangle. So if you know all the three sides of the triangle, then use this formula. We get other trigonometric ratio. So like G, sin A. What is sin A? That is perpendicular upon hypotenuse. So perpendicular is here 4K. Hypotenuse 5K. So that is 4 by 5. K divided with K. Then cos A, that is base upon hypotenuse. Now here base is given as 3K and hypotenuse 5K. So cos can be 3 by 5. Now tan is already given, so no need to find. Then reciprocal of sin, that is cos A, and that is the reciprocal of this. Or you can write here S upon P, or 5K upon 4K, that is 5 by 4. Then sec A, directly you can write which is reciprocal of this, or you can use formula sec A as S upon reciprocal of tan A, or it is B upon P, right? That is B 3k. So this is 3 by 5. So other trigonometric ratios are sin A 4 by 5, cos A 3 by 5. So you can write therefore other trigonometric ratios are. So write all these: sin A 4 by 5, cos A 3 by 5, cosec A 5 by 4, and sec A 5 by 3, and cot A equal to 3. So with the knowledge of this formula, you can easily find all the trigonometric ratios. Clear? So similarly, you can solve any other problem regarding this. Clear? So in later section, we have to see how to solve the different problems using these trigonometric ratios. So these trigonometric ratios are very important figure in the field of the trigonometry. Whenever you go for the higher study, mostly all topic or maximum topic will be depend on the trigonometry. Clear? So this is the basic, like in English, like in LKG or nursery, we are taking ABCD. Similarly, in trigonometry, what is the ABCD of the trigonometry? That is sin A, cos A, tan A, or cosec A, sec A, cot A. And that can be easily you can learn by this short formula, 20%. So in this order, that is sin; in reverse order, that is cosec, sec, cot A. Clear? So very important topic you have to learn, revise.